So in a past video, we've learned about higher derivatives, and so what we're now going to do is talk about finding the second derivative of an implicit function. Okay, so remember in the previous video we learned that we can just differentiate y to get dy by dx, even though it's when it's within the function. So we're going to talk about that and then further differentiate it to the second derivative. Okay, so the steps are going to be differentiate this firstly, rearrange for dy by dx, and then differentiate. Okay, and the other thing key point here is final answer only in terms of x and y. So that means when you further differentiate it, we don't want any dy by dx's, which is why we differentiate, which is why we rearrange for dy by dx. Another reason for that is because then we can substitute in. But it all makes sense when we get there, hopefully. So, first step, differentiate. So prepare to differentiate. Okay, so what's the derivative of x squared? It is 2x. What's the derivative of xy? Well, that's going to be product rule. So differentiate the first, leave the second, add, leave the first, differentiate the second. d by dx of 3 is just 0 because it's just a constant. Okay, so we've got 2x plus y plus x dy by dx equals 0. Let's rearrange that for dy by dx. So we get negative 2x minus y. So dy by dx equals negative 2x minus y all over x. So that's the first derivative. But I didn't ask for that. I asked for the second derivative. Massive spider out of video has just crawled onto my desk, so I'm going to just click that away. Oh, anyway, so dy by dx equals negative 2x minus y over x. So let's differentiate this. You can tell that if we differentiate dy by dx, we're just going to get d squared y by dx squared. And then we need to differentiate each of these terms. Okay? But if we think about this, this is actually just quotient rule. Okay? So I'm going to scribble that out. That spider's throwing me. I'm not thinking properly. So differentiate the first line and leave the second. And so we're going to get negative 2 minus dy by dx times x minus negative 2x minus y times the derivative of the first of the bottom line is 1 all over x squared. The main thing is I don't actually know where the spider is right now, so I'm a bit like half expecting it to appear out of nowhere. Maybe it'll make an appearance in the video. So let's simplify that before we then finish the question. Minus 2 minus dy by dx all multiplied by x. That is minus bracket negative 2x minus y, so it can just become plus 2x plus y all over x squared. And this is what I was meaning about I want my final answer only in terms of x and y. That's not there right now. So we want to get rid of that dy by dx, which we can because we know that dy by dx equals that function. Like that. Okay? So we probably could then simplify that. Let me run out of space. So we've got negative 2 minus negative 2x minus y all over x all over x squared. So yeah, break out the brackets and we're going to get negative 2x plus, because that's going to multiply that out, 2x plus y times x all over x plus 2x plus y, which means that's going to cancel out, all over x squared all over x squared. Can you still see that? Yeah. It's actually going to cancel out a lot. So we're just going to get 2x plus 2y all over x squared. So it looked horrific at one point, not helped by a spider, and eventually I got there, and it's simplified down to 2x plus 2y. And I've also learned that I should maybe leave more space for my questions when I do these videos. Okay, so I'll leave that there in case you're wanting to take a picture or thing it. I'll try and get it all in at once. Well, no, it's not going to work. Okay, before we move on to the next question. Right, so show that if x squared equals e to the y, then e to the y, the second derivative, plus 2x dy by dx equals 2. So maybe something we've not really done before is using y dy by dx and d squared y by dx as actual parts of an equation, and it's maybe kind of preparing us for something later on in the course when we start looking at differential equations, and that is when you have derivatives. So it's, you can start thinking of maybe the derivatives as being essential parts of the equation. They do represent just the gradient at a point, so we can treat these as variables within the equation, and so we can actually use them. Okay, so what we can do is, looking at this, I need to show that this equals 2. So firstly, I'm going to need to know what dy by dx is, and also d squared y by dx squared is. So let's differentiate. Okay, so let's differentiate x squared, and we get 2x. And then differentiate e to the y, so we get e to the y times the derivative of what's inside the brackets, which in this case is y. So it's dy by dx. So let's rearrange that for dy by dx. And we're going to get 2x over e to the y. Okay? So then I now want d squared y by dx squared. Hopefully you can see that that's quotient rule. So it's going to be quotient rule, and within the quotient rule there's going to be implicit differentiation and chain rule. So it's all building on previous things we've learned. So differentiate the top, leave the second, the bottom I mean, subtract 2x, differentiate e to the y. Well, actually we've already differentiated that, so I can straight away say it's just going to be e to the y dy by dx. All over e to the y squared. Okay, distinguish these. And so then let's simplify that. So it's going to be 2 e to the y minus 2x e to the y. We don't want dy by dx in the equation, so we can replace that with just 2x over e to the y all over e to the y squared, which is just going to be e to the y times e to the y, which actually just comes out to be e to the 2y. And then we can simplify. All right. Hopefully there's been no issues between the two videos, but this seems to be the video that everything's gone wrong, as my phone died halfway through making this, and I'm not making this video again after my catastrophe with the spider. So I'll just recap. We are trying to show that e to the y over times d squared y by dx squared plus 2x dy by dx equals 2. We're almost there, we just need to simplify this, and then we should be able to do it. So we get 2e to the power y. 2x times 2x is going to be 4x squared all over e to the 2y. Now, it's a reasonable way to express d squared y by dx squared. So let's now do this. So we've got e to the y, d squared y by dx squared, plus 2x dy by dx and we want to make that sure that equals 2. Okay, so what we can hopefully see is that that's e to the y is going to cancel with one of them. So we're initially going to get 2e to the y minus 4x squared all over e to the y plus 4x squared all over e to the y. They've got the same denominator, so we're going to get 2e to the y minus 4x squared plus 4x squared all over e to the y. They're going to cancel out, and so we're going to end up with 2e to the y over e to the y, which they're now going to cancel out, and that equals 2, thankfully. I mean, at this rate, I think anything could happen with this video. Right, so hopefully that's shown you how second derivatives of implicit functions happen and how badly I deal with spiders. I'm actually fine with them usually, however, not when I least expect and I'm trying to finish a video. Right, see yous.